From beautiful bird's nests to intricately constructed beehives and massive ant colonies, I'm counting down 15 of the most remarkable paleoburrows. Giant prehistoric sloths once roamed South America, and in their wake they left behind something extraordinary: massive tunnels known as paleoburrows. These ancient tunnels, sometimes stretching up to 2,000 feet long and over 6 feet tall, are scattered across southern Brazil, posing an intriguing mystery. Long before humans were carving out cities or complex tunnel networks, these enormous creatures were shaping the landscape underground, making them some of the earliest known architects of nature. The discovery of these paleoburrows was an accident. In the early 2000s, Brazilian geologist Heinrich Frank was driving near a construction site when he spotted an unusual hole in the hillside. Curious, he returned to the site weeks later, crawled inside the tunnel, and noticed distinct claw marks on the ceiling. This was no ordinary cave formed by natural processes. These markings indicated that aligned with the deep claw marks, indicating the methodical work of these prehistoric diggers. Number 14. The sociable weaver. So the sociable weaver bird is a species native to the arid regions of southern Africa, most notably in the Kalahari and Namib deserts. And what makes this small bird remarkable is not its appearance or its songs, but the incredible nests that it builds. Communal homes that are nothing short of architectural marvels. Unlike most birds that build small, hidden nests, the sociable weaver constructs these enormous multi-generational nests that serve as an entire apartment complex for its community. These nests are among the most impressive bird structures in the world, weighing up to a ton and spanning up to 20 feet across. They can also stand 10 feet tall, housing over 100 individuals. The structure grows continuously as the new pairs of birds add their own apartments, often expanding over successive generations for more than a century. Construction strengthens the colony, and it ensures the maintenance of their massive shared home. Number 13. The pufferfish. In the ocean near southern Japan, mysterious patterns have been spotted on the sandy seafloor. These intricate geometric designs, some stretching up to 7 feet in diameter, resemble crop circles. First discovered in 1995, these underwater formations, found nearly 80 feet below the surface, remained a mystery for years. Divers began referring to them as mystery circles, but no one knew who or what was responsible for creating them. The mystery persisted until 2011 when researchers finally uncovered the truth. The elaborate designs were being crafted by a species of pufferfish, a small fish only about 5 inches long. What seemed like an underwater riddle was actually a sophisticated part of the pufferfish's mating ritual. These patterns were not mere displays of art, but functional, meticulously crafted structures. Now, to create these impressive circles, the male pufferfish worked tirelessly, swimming back and forth across the display, darting back and forth through the sandy center. If she deems him and his creation worthy, she will lay her eggs in the middle of the circle. Number 12. Himalayan giant honeybee. In the Himalayas, where only a select few dare to venture, the Himalayan giant honeybee reigns as one of nature's most amazing builders. It's known as the largest honeybee species in the world. This giant bee is a marvel of adaptation. Now, these bees live in some of the harshest environments, where their nesting habits not only set them apart from other bees, but also make the process of harvesting their honey one of the most dangerous undertakings in the world. Unlike their more familiar relatives, the Himalayan giant honeybee builds nests on the sheer faces of cliffs, clinging to vertical surfaces with impressive precision. The honeycombs, exposed on all sides, can grow up to 5 feet long and about 3.5 feet wide, making them some of the largest honey structures in the world. Their nests are often found with the bees exposed to the open air, unlike bees that build hives in enclosed spaces. This species constructs these open-air nests on south-facing cliffs, ensuring maximum exposure to light, which helps regulate the hive's internal temperatures. Number 11. Caddisflies. In the world of insects, few creatures do stand out as much as a caddisfly. While other larvae spin silk cocoons or burrow in the earth, caddisfly larvae take a different approach, building their very own portable shelters. These shelters, often called cases, are not only a marvel of natural engineering, but also a pretty cool example of adaptation. This larvae don't just survive in their watery world, they thrive, using the materials around them to construct intricate structures that serve both as armor and refuge. These larvae, which live in lakes, rivers, and streams, are master builders. As soon as they hatch, these larvae begin constructing their cases from whatever materials are available. Sand, pebbles, leaves, twigs, barks, and even snail shells are all debris, rock, or shells incorporated into their case not only provide armor, but also help the larvae mimic the environment, adding an extra layer of defense. Number 10. Wasp nests. When thinking of those industrious creatures in the animal kingdom, wasps may not be the first one to come to mind, yet these insects are remarkable builders. Their nests are made from nothing but chewed wood and saliva, and they serve both as homes and nurseries for the colonies. Understanding how these nests are made, how long they last, and their scale can shed a bit of light on the fascinating lives of these oft misunderstood insects. Wasps begin their nest-building process in the spring when the queen wasps emerge from winter hibernation. Unlike honeybees where workers survive the winter, most wasps die in the colder months, leaving only fertilized queens to carry on the colony. These queens set out to find a suitable location, often sheltered in areas like tree branches, under eaves, or inside abandoned buildings. The queen then chews on weathered wood, usually the entire construction process is a collaborative effort between the queen and her workers. The workers focus on expanding the nest and tending to the eggs. The queen's role shifts to laying more eggs. The workers not only build the rest of the nest, but also defend it and take care of the developing larvae, ensuring the colony's survival. Number 9. Montezuma oropendolas. The Montezuma oropendola is one of the most fascinating bird species in the tropics, known not only for its striking appearance, but also for its nest-building skills. The birds create some of the most elaborate nests in the avian world, far different from the simple bowl-shaped nests found in backyards of more temperate regions. Their nests hang from the highest branches of trees, swaying like pendulums in the tropical breezes, and they represent ingenuity of these birds. To understand their nesting behavior, it is essential to explore their habitat, social structure, and the intricacies of how they construct their homes. They thrive in forest canopies at the edge of protection from predators, keeping the eggs and chicks far from reach. Using their beaks like weaving tools, they create a sturdy, basket-like structure that's anchored securely to the branches of a chosen tree. The nests are open at the top, but are deep enough to provide safety for the eggs and chicks. Their nests are colonial, meaning the birds build their nests in close proximity to one another and on the same tree. The sight of dozens of these long, pendulous nests swaying together in the wind is one of the most iconic images of the tropical forest where they live. In larger colonies, up to 172 nests have been recorded hanging from a single tree. Number 8. An Argentine ant colony. So ants are among the most industrious creatures on the planet. They're famous for their highly organized colonies and complex social structures. But the Argentine ant supercolony takes that to an entirely new level. Spanning multiple countries and operating almost as a single organism, this supercolony defies what most people think ants are capable of. Argentine ant supercolony begins in the 18th and 19th centuries, when Argentine ants were transported out of their native South America, likely as stowaways on ships. By the 1840s, the first recorded sighting of these ants outside South America happened on Madeira Island, off the coast of Portugal. Once introduced to Europe, the ants thrived thanks to their adaptability and lack of natural predators in their new environment. As they spread, they outcompeted and displaced native ant species, creating one massive interlinked supercolony that now stretches across southern Europe. Now, normally ants from different colonies will react aggressively when they encounter one another, even if they're from the same species. However, scientists have found that the Argentine ants from different parts of this vast supercolony recognize each other as members of the same colony, showing no aggression. This level of cooperation across thousands of miles is practically unheard of in the animal kingdom. Moving on to number 7, bald eagle's nest. Bald eagles, America's national bird, with impressive wingspan the size of a small car, only far heavier. Bald eagles typically build their nests from a mixture of sticks, grass, and moss, creating a sturdy platform high in trees that can support their weight and the weight of their young. Most of their nests are found in tall trees, often more than 66 feet above the ground, providing some safety from predators and a good vantage point. The massive size of these nests raise an obvious question: how could it have grown so large? Well, the answer lies in the bald eagle's nesting habits. Bald eagles mate for life, and instead of building new nests each year, they return to the same one. Each year, they add new material to the existing structure, usually between 1 to 2 feet of fresh twigs, grass, and moss. Over time, this adds up, and after years or even decades of use, a nest can reach enormous proportions. But most bald-eagled nests, while still large, are nowhere near the size of the St. Petersburg nest. Typically, a bald eagle nest measures around 5 to 6 feet in width and about 3 feet deep. These nests are already impressive and easily capable of holding up. Structures are not just nests, they're masterpieces of color coordination, optical illusions, and competitive creativity. These nests are built primarily by males to woo potential mates, and they're not nests in the traditional sense, but elaborate courting stages designed to impress. Different species of bowerbirds have their own distinct styles, but in general, a bower consists of an arch or avenue made of sticks. Surrounding this structure is a carefully curated collection of decorations: berries, flowers, leaves, feathers, and in some cases, man-made objects like plastic bottle caps, pens, or even a piece of glass. For satin bowerbirds, one of the most commonly encountered species in Australia, the preferred color scheme is blue. Their decorations range from natural items like blue flowers and feathers to modern things such as plastic bottle caps, laundry pegs, and pen caps. But despite it all, it's said that the males are incredibly picky, ensuring that each item is placed just right to create the perfect display. Further away. This gives the illusion that the male bowerbird is bigger and more impressive than he actually is. Moreover, researchers discovered that bowerbirds carefully arrange their decorations to affect the female's perception of color. The reddish sticks of the bower can enhance how other colors look, like green and lilac, are perceived by the female, creating a sensory overload that seems to mesmerize the onlooker. Male bowerbirds also display their most prized objects one by one in a non-random order to create maximum impact. It's almost like they're performing a well-rehearsed magic show. Number 5. Cliff swallows. The cliff swallow is a remarkable bird that showcases not only an exceptional nesting habit, but also fascinating social behaviors. Unlike many solitary birds, cliff swallows thrive in colonies, where they build intricate mud nests that resemble tiny hovels. They are highly social songbirds found in large colonies, often comprising over 2,000 nests. Their gourd-shaped nest, constructed from mud, features small nests of their neighbors. Living in such close quarters offers both advantages and some challenges. The colony structure facilitates information sharing, allowing birds to learn about food availability and potential threats quickly. However, this proximity can also lead to the rapid spread of parasites and diseases. When swallows return to their nesting site at dusk, they often perform synchronized flights in tight formations known as creches, resembling a single large organism. This behavior not only serves as a stunning spectacle, but also enhances their safety from predators, as alarm calls are communicated swiftly among the birds, prompting a mass evacuation when danger is near. While new nests may reduce a parasite load, they require significant time and energy to build, which can delay reproduction and impact chick survival. Thus, many pairs may opt to reuse nests, demonstrating an understanding of the trade-offs involved. Number 4. Horse ants. The tiny to us, yet massive to them world of ants is filled with fascinating behaviors clearings. In fact, their size can be so substantial that one might easily overlook them if not specifically searching for them. At first glance, a mound may appear simply as a pile of organic debris. However, these mounds are carefully constructed with internal chambers and tunnels that provide ventilation, nursery areas for larvae, and space for the queen and worker ants. Now, horse ants are inherently social creatures, often living in colonies that can house anywhere from 100,000 to 400,000 individuals. These colonies frequently form large networks of interconnected mounds, allowing them to communicate and share resources. Construction of a mound begins when worker ants collect mud, plant materials, and other organic matter. They work together to use their strong mandibles to shape and compact the materials, creating a sturdy structure. The ants recognize their nestmates through unique chemical agents, which play a crucial role in maintaining their integrity. The colony's success is bolstered by a shared knowledge of food locations, allowing them to thrive in challenging conditions. However, this close proximity also increases. 3. Ant bridges. Okay, so we've talked a lot about ants today, but this time around it's a bit different. This remarkable structure is one made of the ants themselves. One remarkable aspect that sets certain ant species apart is their ability to form living bridges using their own bodies. This fascinating behavior not only exemplifies their remarkable collective intelligence, but it also serves as an extraordinary survival strategy. The phenomenon of ant bridges is predominantly displayed in certain species of army ants. When faced with gaps between leaves, branches, or uneven terrain, workers instinctively come together to create a bridge. This process isn't directed by a single leader. Instead, it emerges from the collective actions of numerous ants. The ants utilize their bodies to link together across the gap, forming a continuous line that allows other members of the colony to cross efficiently. The number of ants required to create such a bridge can vary, with studies indicating that anywhere from 1 to 50 ants may participate in a single bridge. The strength of the and researchers have observed that the ants assess the benefits of forming a bridge against the potential loss of foraging efficiency. Through this behavior, ants demonstrate a sophisticated form of decision-making. They form bridges when the gap is just large enough to warrant the investment of their fellow workers, but not so large that it requires too many ants to be pulled away from other essential duties. Researchers have conducted experiments to study how ants navigate obstacles and assess when to build bridges, and their findings have profound implications, not only for understanding the complexities of ant behavior, but also for insights into developing cooperative algorithms for robotic systems. Number 2. The world's largest beaver dam. In Canada's Wood Buffalo National Park lies an amazing piece of animal architecture and nature's engineering, the world's largest beaver dam. Stretching approximately a half a mile, this massive structure is a result of decades of relentless toil by beavers, showcasing their ability to shape the environment for various aquatic species and promoting biodiversity in the surrounding wetlands. The beavers are currently expanding their architectural efforts, building additional dams nearby that may extend the total length by over 300 feet. The construction of their dam is a multi-generational endeavor, with each successive generation of beavers contributing to the expansion of these structures. In a sense, the largest beaver dam is not just a singular achievement, but a collective legacy of beaver families over decades. The isolation of Wood Buffalo National Park has allowed the beavers to thrive without significant human interference, ensuring that their monumental structure remains intact. Number 1. Compass termites. The compass termites inhabit the semi-arid thorny scrub forests of northeastern Brazil. These insects are celebrated for their architectural achievements. The most notable of these structures is a sprawling complex of approximately 200 million mounds, which covers an area about the